This tutorial could have been 3 minutes long. It could have been real damn simple. Let me show you what I mean. Here we go. Splitter. Look, here's the intro, okay? This is a triple assembler, okay? It really could have been this simple if I had just stuck to my lane and just stuck with a triple assembler and not investigated anything, right? Here we go. Look, go back to my compact building tutorial. You'll see what I'm doing. This is real basic stuff, right? These are the two inputs for the main machine. And then we have this lift going to this one and this lift going to this one. And we just weave them around each other like this, bang. The inputs are done, okay? That's how you do a double input with a 1 to 3 splitter on each one for a triple assembler. And the output's real simple, right? It's just like this, okay? We just go like that, we grab a merger, and if we want to be real fancy, if I wanted to really manufacture some content, I could be fancy and put this one out here, or I could set this one in. It doesn't matter, this thing isn't that long. We don't need to compactify it. We don't need to be fancy. We can just do this, right? Nothing wrong with this. Slight bend to the belts. Who cares? We're done. That's the triple assembler, guys. You can frame it up. That's cool. Go home. There's no hidden depths to this topic in defiance of literally every other topic in the broad spectrum of human understanding. And I could have just gone on believing that if I didn't think, you know what? The reason this is easy is because you can only fit one row of assemblers in a Mark I blueprint designer. Maybe I should investigate that. You know, like a fool. And then you realize that this bounding box has half a meter spare, so you just press Control and you hold it and you move it in. And oh God, oh no, there goes the weekend. I need to make a tutorial explaining how to make this assembler. So we have, and that's what the rest of the tutorial is going to be about. I apologize for the attitude. I don't blame anyone but myself. Okay, so this is the hex assembler, and the basic principle of how to understand how to design this is just to look at the balances, right? This is a balance that just goes from 1 to 6, and this thing also goes from 1 to 6, and so on. So you can imagine that the end of each of these belts is one of the machine inputs. If you think of these things as being on layers, we've got layer 1 of the splitters, and then layer 2 of the splitters. And the same thing happens with the mergers. And the job here is to keep in mind how this structure works. All these inputs are going to be interleaved with each other, and then the outputs are also going to be interleaved with some of these inputs. Now we need to stack it into a Dodeca assembler, so we need another layer of the splitters and mergers. And again, we have two tree structures, the A and the B for the inputs and a single tree for the outputs. Okay, and one of the ways that I keep track of that structure is I basically just keep in my head names for things. Like this one here is input A, and then this goes to the top layer, and then the front row of the top layer, the back row of the top layer, and then bottom layer, front, and back. And I do the same thing for the other structures as well. In general, in design, finding the appropriate names for things can be a really good technique to keep things clear in your head and help you clarify exactly how you want to think about them. And then you keep that into your head as you cram it down into the space you've got available, which in this case is defined by basically the bounding box of the assemblers. Almost the entire design is going to happen inside those bounding boxes. And the real trick to this is that there is no shortcut here. When you're cramming things in tight like this, there's no substitute for the fact that you just have to iterate over and over again. You just need to find new and more efficient ways to cram things into the space that you've got available. Oh, that doesn't work there. I don't have space for this. I need to move this a little bit more, shift this over a little bit, until you finally find something where everything fits. So just quickly, the point of this design is to take a whole bunch of machines and cram them together so you can treat them as one big machine. And that reduces the complexity of a big factory. My compact blueprint tutorial deals with this. That link is in the description. Another piece of important information is this compact building technique that I made another tutorial on, but the short explanation is there are different offsets for lifts and different offsets for splitters and mergers. So -1 offset all the way to +2, -2 all the way to +1, and I'll be using that terminology throughout the video. So if you're confused, that link will be in the description as well. If we're going to do this without excessive clipping, the first thing we need to do is check the animations of these arms. So what I do, I put a long-running recipe in here, and I downclock it to 1%, and if you do the maths, you can see how long I've spent preparing this tutorial. This is just a subject study, you know, it's just checking out the animation is, and normally I wouldn't go to this much trouble. Pop it there, maybe we'll grab it, painted beam. Oh no, okay. No, okay, so that is definitely the limit. Okay, side to side, yeah, you can see that. So we really don't want to go any further than that. This is just to give you an idea of what's going on in my head when I look at this animation. So that's basically pretty much the bounding box of that animation. Oh yeah, okay, that is actually the limit. You've pretty much got that kind of bounding box. And the top of this animation is just this frame here, so it's fine. That just gives you an idea of the kind of limits I'm working within in order to avoid this animation and clipping through it. Okay, we're going to get into the hex assembler now. The first thing to remember is that this middle machine is centered, right? There's no space front to back. It's right in the middle. We're going to need space either side for things later on because we can't move any belts up and down out here because there is no space. Now we've got 1 to 3 splitters at the back. I'll just quickly build them. You've already seen me do this, so I won't waste time with it. Okay, there it is. Very simple. You've already seen it. We're kind of weaving the belts around each other. Here at the front, we don't have as much space. We need to cram everything in against this wall here. And we also need more space above for the extra splitters. And it turns out the best way to do that is to keep one of the input belts in front of the other one. We're not going to do any weaving. So we're going to keep this fairly simple. We're going to get this right up against the edge. And we're going to build it up here 3 times. And this is just scaffolding. I'm just going to attach this here, get rid of it, attach this here with the input coming from the back. Now, in this one, we kept the 2 inputs in the middle because there was no reason not to. In here, it makes sense to have this input on this side and the other input aligned with this input. Okay, now, also, when I'm putting these in, you can see that I'm actually insetting these. How much is this inset? I imagine it's -1.5, but I don't really know. What I'm actually doing is I'm just measuring against the back of the machine and using the splitter to gauge that. Now we need to get this splitter over to here. And we're going to go from this output up and across and down. Basically, we're just going to add some more scaffolding, line this up with the input, bring it up by 1, hold it, bring it back by 3, and that will locate our lift here. So we're going to get some more scaffolding. We're going to go up twice, hold, back by 2, and that should give us space to make another lift, which is flush with this lift. I'm going to get rid of that, and we're just going to attach this directly on. Again, input facing backwards. And that gives us room to send this belt up and over and down. Now we're going to set some scaffolding, and actually the simplest way to do this, if you wave over this machine, it doesn't work. So the best way to do it is just hold this here. Even though it's clipping the blueprint designer, it doesn't matter. If you hold it and move it in, then it'll work for you. Now we're just going to click and move it up so that it's just clearing this. There we go. Snap it in. And now we've got a belt that is... The only reason for this lift is to turn the belt in a very tight corner, completely flush with the front of the machine. Now we're going to do something similar over here. We need to reverse it again. Hold, bring it in, give it the correct amount of offset. And I'm going to attach this one, bring it in, snap OK. Now it may not be strictly necessary to add the lifts in the place where I'm doing it, but I'm just going to do it like this, just to keep things as tight as possible. We also need to add another lift here. This is a case where we need the rare double scaffolding. We've got 1 lift there and 1 lift there, and we'll just add another lift between them. There we go. Delete those 2, and then belts. The one thing that this drop down here buys us is the space to add a belt in this particular spot. So we're just going to bring it up here. Hold. Yes, that's the correct offset. Bring it down, snap it in. And then we've got a belt here. You can set it to straight mode. And we need to get a belt from here over to here. But we need to remember there needs to be a lift coming down into this splitter. So we need to move it to the left a little bit and just get it around that. And the simplest way to do that is actually pretty simple. We're going to use straight mode again. 1, 2, 3. Build these up. And we put a lift here. Now, in theory, that would work. I'm just going to use a compact lift over there to do the same thing, only down a little bit further, because I want to be able to use this space without any restrictions. So we're just going to grab this, put a splitter underneath, hold, 1, 2, 3, 4, 5. Okay, and then we can just clip this into here. And that's not going to encroach on the animation. We'll be just fine. So now we just get a belt here, attach it here, and it just cleanly weaves around. So just when I was editing, I looked back on this, I realized that these lifts in this belt showcase an issue that for me is mostly a non-issue, but someone complained about this in the comments, and I realized this is something that can be easily cleared up, right? When a lift is built inside a machine, like this one is, you can see that the cowling inside the machine is extended. When you build the lift on its own, the cowling extends by 1 meter. When you build it inside a machine, you can see that the cowling extends 2 meters. In this case, it extends to the edge of the splitter or the merger. But then what we've done here and here is we've done that and we've extended the cowling, and then we've deleted the merger or the splitter that we used to build it. And now when it's exposed and extended, it looks kind of goofy. There is no good way to say that, so I'm just leaning into it. And I'll just quickly show something else. We'll just build this one and we'll snap something inside of it. When this lift is built already and you snap the splitter to it, the cowling doesn't extend, right? And that's because the cowling is set at instantiation time, right? This is an object in the game world that has to be instantiated, right? Basically just means it's created in the game world. However, we can fix this very easily. In fact, this problem basically fixes itself. We'll just save blueprint and then we will load blueprint and we've reinstantiated them. And now that they've been reinstantiated, the appropriate cowling lengths are set. You can see that this one still has the long cowling, this one has the short cowling, short, short, and here has a long cowling, right? Because that one was instantiated inside a connection. So this happens whenever you place a blueprint, whenever you reload a blueprint, or whenever you reload your game save. So if you see this issue and you don't like the way these look, I've seen someone say that they won't use these because they look ugly when they've got the extended cowlings. Just reload the game. The problem solves itself. Okay, but there we have it. We've got a 1 to 3 splitter here and a 1 to 3 splitter here, except that their inputs are backwards. We've also got the 1 to 3 splitters there, and their inputs are forwards, pointing towards the middle. That is potentially useful. Now we're going to add another splitter here with the input facing forward, and we're going to hold it. We're going to go forward twice and then across. So we've got scaffolding here that's going to add a lift in between the two. So here we go. Snap it. Delete that one. And there we go. Now this is odd. Why are we putting a splitter here that's going to feed these two, but the entrance is not at the start of the machine? That's because we're going to have another extra splitter here that is at the moment redundant. Okay, this is an intentional part of the design. We're going to add it here, and then we're just going to add a belt between them. Okay, and this is the actual input of the machine. What we're going to do with this later is, when we stack these on top of each other, one of these is going to get deleted, and we're only going to use one, which is then going to send a belt out to the side, up and across, and into this splitter. So that then this splitter is going to end up feeding both the bottom and top machines. But for now, it's just providing us with a convenient input. Okay, now we're just going to do a quick compact belt here. Hold, 1, 2, 3, 4, 5. Click, do. Some of this doesn't need to be as compact as it is, but it's just a habit at this point to build it that way. So we'll call this one input B. Input B is done. This is the extra redundant splitter, goes to this one. This splitter splits to these two splitters, and then this one splits to all 3 back machines, and this one splits to all 3 front machines. And we'll do the same thing on the other side in just a minute. Okay, now we're going to make a non-compact but fully inset splitter. Input facing to the left, 1, 2, 3, 4, 5. Delete that, and then we're going to snap this in, delete that one, bring the splitter back, make sure that the input is correct again, because it changes when you snap it to a lift head, which can be very annoying. Add another one here. 1, 2, 3, 4, 5. Click, click. Delete that. Snap it in there. And then we're going to go like this. And just quickly, I'll just hold this. It actually doesn't matter which way you put this belt. It doesn't get in the way of anything. So that's nice. And then we're going to have another splitter here. And I'm actually going to put it over here with the input facing outwards. This is our actual input for the whole machine. Now, there's a couple of reasons why I've got this down here. First of all, when I have multiple inputs, I prefer to have them not only on different columns, but also on different rows. And that way, if you're coming in from above or below, you've got them on different columns. And then if you're coming in from the side, you've got them on different rows. It's fairly easy to supply them that way. It also works out really well here because this little compact lift just allows us to put this down here quite easily. And there we go. This splitter goes to the back here, which feeds all 3 back machines, and to the front here, which feeds all 3 front machines. So we have input A and input B working for all 6 machines, we hope. Okay, so the inputs are done. And the reason I knew this would be fine when I was designing it is if you look here, there's a clear space above all of these outputs to send the mergers. So no worries about that. So I'm going to grab this one, and we're going to bring it up to here. And we already know that we only want the machine to be 11 meters tall. We'll just quickly double check this. And the reason I say 11 meters is because that's the top of these. If you have these things sticking out the top, then you can't stack the blueprint. It doesn't work at all. Plus, it also looks bad. So 11 is the absolute minimum height that we can do. And it turns out we actually can build this within 11 meters. So we've got that there. We're going to add a merger here, hold it, bring it across. We want it in line with that. And then we need to use scaffolding to get another lift down. So we're just going to hold it. 1, 2, 3. That gives us space there. Gives us, I think that's a flush offset there. And there we go. And we should be able to just attach these. Whoops. We should be able to just attach these directly. Yep, no workers, mate. And same thing here. No need to be fancy. This one's very, very easy to build. We got plenty of space in this end of the machine. So there we go. There's the merger. And we're going to do the same thing at the front, except slightly different. So we're going to go up 3, and then the fourth one, we'll just bring in by 3. And that allows us to inset this lift. And then this merger will be reset over here. And the output is going to go to the side. Again, this just seems to me to be the best way to do it out of many, many possible alternatives. We're just going to go underneath this one to get a snap to it. There we go. Boom. Now we're just going to hold it, bring it across. Put a belt in there. Attach it that way. Having these insets so far just gives us a bit of space to put some beams over here later. Now we're going to add a merger here. 3, 4. Those. Snap it in. Okay. Now the only reason we've done this tricky thing here with the belts and the inputs and so on is so that we can put another merger right on top. We don't need a redundant merger for this one because we don't need to worry about balancing anything here. We're just going to take everything directly into this merger, and this will be the final merger for the whole machine. Add it here, make sure it's facing outwards. Okay, and that's done. So those are all the mergers and all the splitters. Again, it looks complicated, but it really is just about squeezing things in and getting them out of one another's way. And once you're fluent in the compact building techniques, it gets pretty simple to do this stuff. You just need to spend the time mentally keeping track of where all the splitters and mergers are. This is layer 1, layer 2, and this one's on layer 1 as well. And then this one's extra, and it will become layer 3 later. This one here is splitter layer 1. This one is splitter layer 1, and then splitter layer 2, and then splitter layer 3. And the mergers are a little bit different, but basically at this point we've got merger layer 1 and then merger layer 2. So as long as you get all the mergers and splitters working, and we can just quickly double check, yeah, I don't think that's going to get in the way of any of those animations, and nor those. That's obviously clear. And over here, yep, that's pretty clearly clear as well. That actually, is that going to get in the way? We can compare to this beam here that we've put here. We know that that has space for that animation. I'm going to check it back over here. I think that will be fine. There might be a slight clipping just at the top there. I don't think it's a big deal. Okay, now we've saved this as the tutorial. I'm going to quickly check the inputs and outputs. Assembler V2 tutorial. Face it the right direction. All good. For the test, we're going to do black powder. It's a very quick recipe. It's very easy to calculate. It's 1 per machine. We don't have to worry about like multiples and so on. We're just going to grab 30. 30 is in fact divisible by 6. Just quickly checking in my head there. Okay. Boom. Boom. Everything goes green. This animation. It's the only one that I was... oh no, actually looking at it from this angle, it's fine, isn't it? Yeah, no, that's not going to be an issue at all. And now we have 60, which is the correct number. So those balances all work. Everything turned on and off. No worries. So now I'm just going to frame it all up. With the frames, we get them onto the half grid. And in this case, we're going to slam them right up against the front and back of the machines so that we've got space for these belts in and out of the sides. And that's how we're going to connect them vertically. 11 meters tall for all of them, right at the front. As long as we do 1 half step in each direction, we know that we're on the proper grid that we want. Here as well, this is just for aesthetics. I know I said that I don't really care about architecture. What I do care about is structural engineering and making things look like they could stand up. And just beams to me, like they give something a more purposeful look. And you could argue that this is architecture, you know, fine. Now I'm going to add the frame on top, on the right grid, underneath itself, delete, hold, bring that across. We happen to know that this blueprint is exactly the same length as a blueprint designer. We just build the frames and zoop them. Very, very simple. Now we're also going to add a couple extra beams. Just going to bring it up to here, hold it. Yep, just roughly in the middle there. Looks pretty good to me. Again, that half step, just for the look of the thing. Hold. There we go. Perfect. Bring it across, click, and it's done. This might be an excessive amount of beams. I like beams. I think beams are nice. We're just going to put wall outlets here. I think you can see the basic idea that I've attached these outlets to these beams and just use that to route the cables. If you want more details about how I did this, you can study the actual blueprint that I'm going to upload. There is nothing terribly detailed or technical going on here. With one minor exception, this outlet goes here and attaches up to here and then over to here. And the only reason for that is to get out of the way of a belt that's going to come up or down here, depending on where we are in the vertical stack. But this is largely subjective. You can just put the cables wherever you want. This, however, is not subjective. You absolutely must paint these carbon. I'm sorry. If you don't agree with this, then I'm out of flipping insults. There you go. That design is done. Save blueprint. Now we need to turn off power. So we're turning off no power. Brace your ears. Everything powers down. When you do that, grab the blueprint. It's going to attach everything. Power. Going to attach there. No power because the nuclear power plant was off. Yep, that's good. Copy, paste. When you see the lights turn yellow, you know that it's worked. Yep, we're all good. Let's go. Everything's turned green. Maybe redundant doing this test because we've already checked all that stuff, but you know, everything's turned off. We got 60. Perfect test. Validated. Save blueprint. Confirm. Was I recording? I was recording. Okay, just going to get the Hexassembler V2 tutorial. Ugh, it's ugly. Oh, I don't like that. We're going to stack this Hexassembler on top of itself to make the Dodeca, which is 12. But in order to stack them, this doesn't work very well because we're not stacking it on a blueprint. Inside the blueprint designer, that's not a blueprint yet. So we're going to clear the designer and we're just going to line this up, center it, click there, put it into blueprint mode, and then we stack the next one on top. We just rotate it till it's in the right position. The arrow goes towards the inputs, and that should stack perfectly. So if you were stacking these out in the wild, that's exactly how you do it. That's the whole point of framing them up. Framing them up gives them this clean connections in between the stacks. Oh, and hey, look, this cowling is fixed, and so is that one over there. Fancy that. Okay, now hooking these up is actually pretty straightforward. Because we added this extra piece here, we can just delete that and get a lift, bring it down the side, connect it there, delete that one, bring this over, and that's hooked up. Same thing on the other side. Going to delete this splitter. And now we do need to do a little bit of work to get the scaffolding over here. But it's not too hard. We're just going to bring it over here so that we've got a 1 meter inset in this area. Counteracts the offset. We can bring it down. And this is as close as possible as it can get. You can't cram it in any closer. Delete the scaffolding. Add the belt. And add the belt. And actually straight mode doesn't even make a difference there because it's so perfectly lined up. So the inputs are done. Now I'll come over and we'll do the mergers. With this bottom one, we'll just delete that merger and we'll add it back with the output facing to the left or to the right, depending on how you're facing. You need to make sure you delete this belt and rebuild it, otherwise it won't work. And then we just need some scaffolding and a lift coming up around the side. Make sure the lift is there, bring it across one and over one, and that should be correct. Remember that lifts have a +2 offset. When you attach them together, that's very hard to remember because the hologram doesn't show you the initial offset. So I find it really hard to remember how to count. Anyway, belt. And there we go. So now this merger feeds into this merger. And this is the output for the entire machine. The only thing left is connect the power vertically. You don't need to do it on both sides, but I do. And there we're done. We just change that to Dodeca, save blueprint, and we quickly test this one. Stacking them is really easy once you get used to it. Okay, Dodeca Assembler V2 tutorial. Okay, so we're just hooking these in. Just want this one to line up. You need to remember the power and take a moment to configure them all. Paste. Just check that they all turn yellow. It's very easy to accidentally copy when you're trying to paste, and then you end up pasting just empty configurations. And we're going to do a test with 60. Okay, so coal and sulfur. And green across the board there and across the board there. Everything's running. And we got 120. So that worked. We're done. Oh, we're not quite done, actually. The last thing is, because I was a liar before and I said I didn't care how things look, and I am actually going to make some concessions to architecture because obviously there's no shear support here. We need to add some cross members. One comes right up and across. With beams, freeform mode works really well when you're connecting beams to other beams because they just snap to the other beams and it's very, very precise. And obviously we've got the 3 shear walls around the outside and the machines themselves are operating as shear walls in this plane. So this wall here, over here, that one's supported sort of indirectly by the other shear walls. I'm sure everyone's familiar with that, so I'm not going to go into it too much. Another thing you can do is just put a square sign here and maybe hold it and bring it across by half like that. And what you can do with this, you can just put an X on it, select icon, and that just indicates to you that this is not a useful input or output or anything. Because if you've got an input and output like that sitting on the edge of the machine, it can be something that you can go, oh, I'm just going to connect to that. And in fact, you'd be wrong to do it. It's this one. So that's an option. Sometimes I do that, sometimes I don't. That won't be in Blueprint. It's very, very simple to add. You saw me do it. If I add that, then anyone who wants to make this Blueprint needs to have quartz, which I don't want to require. So there you go. So there it is, Dodeca assembler. Now I tried as much as possible to give the information about exactly what I was thinking and why I was doing everything. And I hope that came across. But one thing that you miss is the design process. Like I said, there's loads of iterations in this design to just get it to actually work. I've got a bunch of different options. Like I had ones where the inputs were actually coming out the side, but I decided that wasn't really consistent with the rest of my designs. I didn't want to do it that way. That was going to get confusing for me. Another one was I had this splitter on here and this splitter here, and then they were crowding each other, and this extra thing coming over here created problems, and then this thing had to be nudged over by 1 meter, which created this little weird spiral stack of conveyor lifts. And the next iteration was where I realized if I moved this, I could fix a bunch of problems and make everything much easier for myself. And so that's the final design. But that whole process is not something that you get across in an edited video. And I don't know how to do that in an edited video without making it incredibly long and boring and way too much work for me. So I'm thinking, if I'm going to design, say, for instance, this octo assembler or this quindeca assembler, I think you'd call it, or pentadeca. Yeah, I don't know, pentadeca assembler. If I was going to design something like that, maybe it'd be a good idea to design them on stream. And that way, the many hours that it would take to do it, you know, if people are watching a stream, then they know that they're in for a few hours. It might be on in the background or whatever. If people want to load up a VOD stream or whatever, then they know that it's going to be a long thing and I don't need to worry about editing it down. And also any information that I'm not explaining, if there is a chat, then chat can ask questions and I can clarify in the moment. And I don't miss things and have to go back and fix them and clarify them or whatever. So I think that'd be a good use of a stream. So I might do that. Let me know. I might actually set up like a poll in a little while about like what people find is the best time to stream. Bear in mind, whatever time it's going to be, I'm going to make it friendly for Australians because I'm sick of not having stream times that are friendly to me. But I think that'll work pretty well. So that is the tutorial done. Once again, we find ourselves in my main world. You may not recognize what this is. This is the subject of a future tutorial. Flashing lights warning. I'll put a filter over this, don't worry. But anyway, I launched that one a little too hard. Okay, we've got a train station over here. We've got another launcher over here. One thing you may have noticed, my mouse movements were smoother this video. Someone mentioned that this was an issue, and I got to agree. As an editor, I'm looking at my footage going, this is really like jerky and annoying to watch. So what I did was I reined myself in by lowering my mouse sensitivity, and also I went into my mouse settings in Windows and discovered that I have mouse acceleration turned on, or it's called enhanced precision, which is absolutely not what it is. Where am I right now? Wait, this is Bengaluru City A launcher. Oh, wait, what? I got Bengaluru City launcher East. Where's that? This is Bengaluru City Mines. I have an East launcher? Uh-oh. I misnamed something. There we are. Now we can check. 6, 5, 4. That's a good launch time. Actually having a linear mouse input really has helped me to smooth things down a little bit. I really didn't understand why I couldn't stop snapping the mouse, and that was the reason. So I really hope that helps. I'm sure there are some clever clogs that have already figured out exactly how this works. Yep, that's a good time. But the next video I have definitely decided is about these smooth rail lines, which I have actually improved the technique since the last time I mentioned them. They are now smoother and easier to make. I was shocked at how easy they became to make. And I'm also confident enough in my ability to make videos now that I can promise what the next video is about. I couldn't have done that before. This video was delayed by about a week because I had a really bad foot injury. And I couldn't sit at my computer for a while, and I still managed to crank this out even under those conditions. I have yet to upgrade these to the new launcher system, so I'll have to travel a little bit like a peasant for now. Strong chance of getting locked in one of those. See this? Look at that. Bumpy. Uneven curvature. Don't like them. Got to improve that. And I will. Launch it. Boom, boom. You can actually adjust the launching speed by changing the time that you have left when you jump. Can I stick this? We really got to hang on to this fuel. Actually, that's not true. I keep a parachute for exactly this kind of reason. Oh yeah, no, I do have enough fuel. Okay, boom, we're done. It's nice out here. At this point, I'm just throwing out potential outros. There's not enough attention given to the cold outro, where you just end on some random sentence. Wow.